Hi everyone. This video is a short introduction to graph theory. Before I give you the abstract mathematical definition of a graph, I want to tell you a little bit about what a graph does. Fundamentally, a graph is a way of telling someone, if you have like a finite set of things, which things are connected. So in the real world, here are some real world graphs. Let me share my browser with you. So I searched for social network graph, and what you can see, all sorts of different kinds of things. In each of these graphs from a social network, the dots represent people, and the lines between them are edges and represent connections between people. So for example, if the social network is Facebook, then the dots represent people on Facebook users, and there's an edge between two Facebook users if they're Facebook friends with each other. That would be a natural thing to do. There's a big difference between something like Facebook, the kind of graph that Facebook generates, and the kind of graph that something like Twitter generates. Because in Twitter, you would still have sort of dots representing people, but in Twitter, what people have followers, right? So you can follow someone on Twitter, but it doesn't necessarily mean they follow you back. So if you're representing a social network that consisting of Twitter users, probably what you want to do is have some kind of edges that have directions on them. And that's something that's really common in graph theory. What else might be connected that you'd want to represent using a graph? So this is a picture of places that Korean Air flies. I like to fly Korean Air when I go to Korea. And so you can see, what you can see here is that I think that's Seoul, basically, right? That's where Korea is. And the dots here, instead of being people, represent cities, and they're connected. They're connected by a curve, or we call an edge, if there's a flight between those two cities. So for example, you can see that what Korean Air does is it flies from Seoul all over the world, right? And there are a few places in the world, it looks like from Spain to, oh, I don't know what that is. There's a flight that goes from there to there in Europe. There are some flights, maybe that looks like in Los Angeles to, I'm going to say Houston, maybe in the US. It looks like there are some flights here, but most of the flights that Korean Air flies go from Korea back and forth to other cities around the world. And then you can see there are lots of little things here that are hard to see that are going on. Okay, so let's look at the formal definition of a graph. And now I'm going to share my iPad with you. Oops. Let's see. So the formal definition of a graph is, we often call them G, and they consist of two pieces of data, V and E, where V is a non-empty finite set of nodes or vertices. In the Facebook example, the elements of V are the people, the Facebook users, and in the Korean Air example, the elements of V are cities all around the world that Korean Air flies to. And so the graph consists of a finite set of vertices or nodes, and then a set of edges. So the edge set, the way we think of it is it's a subset of the power set of the vertices, with satisfying the property that every edge has cardinality too. So it's a bunch of unordered pairs of vertices. In Facebook, the unordered pairs represent Facebook friendships. And in the Korean Air graph, the unordered pairs represent the fact that there's a flight between two cities. Okay, so let's see how we would use this definition to represent a graph. So for example, maybe my set, so I'm gonna have G equals V, E, and I'm gonna have my set of vertices be the set U, V, W. So there are three vertices. And my edge set So typically, instead of writing UV for an edge, so UV would be a set of size 2. In order to set, for shorthand, we're going to write it like UV. Okay, so my edge set maybe is going to be UV UW, and often it's helpful. What we saw in the 2 examples with the Korean Air and the social network graphs, where we drew them, right? So here you can put your vertices U, V, and W together in a picture. And if I wanted to draw these sets that I just gave, it would be UV and UW, okay? And for a small graph like this, it's often easier just to draw it and you go, oh, that's what it is. It's the three vertices and 2 edges connecting UV and UW. However, if you're talking to a computer, you're probably going to want to specify it this way, where you give the vertex set and then the edge set as a list of lists, where if you're talking to a computer, you'd probably write U comma V and U comma W. Like if you were writing a computer program and you wanted to tell a computer program about your graph. One thing that I always like to say to people, and now I'm going to switch back to the social network examples, is that if you don't know the algorithm that people are using to display their graph to you, you can be really easily manipulated. So why would I say that? Well, look at this one here. What you see is a whole bunch of nodes that are crammed together, and then these nodes get to be sort of far out from the other ones. And it probably what's going on is that these nodes are ones that have a lot of connectivity. They're connected to a lot of other things and they're all in there. And it's trying to show you that these nodes are less well connected. But I could have made other choices when I drew it, because really it's just the set of nodes and which ones are connected. And I could have stretched out this ball here to make it seem more sparse looking, perhaps. So there are lots of ways to represent a graph, to represent this data. And if you don't know how people are deciding to sort of, pop some vertices out and put others in clusters, you can be manipulated by what they're showing you. So what else should we talk about in this little video? Let me go back to the iPad. Okay. What else should we talk about? So there's a small example. So another important definition to know is that if G is a graph, so it's a vertex set and an edge set, and little v is a vertex in V, then we define the degree of V to be the number of edges incident to V. So we'll say that an edge is incident to V if it has V as one of its 2 endpoints, right? So for example, in that graph we had above, I'll just draw it for you. So here's U, V, and W. There's an edge. The edge UV is incident to U and to V. The degree of U is 2 because there are 2 edges incident to it, the edge UV and the edge UW. the degree of v equals 1, because there's only one edge that has endpoint v, and the degree of w is also 1. So I'll have some exercises in a worksheet where you can go back and forth trying to, one, given the data of a graph as of set V and a set E, try to draw it. Then to do the thing that's sort of the vice versa thing, if someone gives you a picture of a graph, can you come up with the set V of vertices and E of edges? And then to try to take a real world situation and represent it as a graph. Okay,